30 minutes. Ladies and gentlemen, good evening. I just wanted to continue my topic, which I was talking about HADOOP environments. And I was sharing with Ali that during my 8 years of developing experience, maybe I can just tell you about two major experience that I had, and I want to share it. And well, the margin that I'm going to tell could be more important than the main parts. For me, it was like that. I remember the time that I shifted from a kind of hygienic company, it was healthcare company, to a banking system environment. It was the largest private bank in my country. I started to do the same thing in order to make a kind of calculation over a large scale database. It was a big scale data, but it was not, a big data for sure. But what happened? I wrote my, as you may guess, my application, and I connected to database with, you remember the time that we used AODB, and after that ADODB, and after that ADODB.net, and I used this version in order to connect to database. And I just made a sample environment for myself containing 50 or 100 just names like A, B, C, and in order to calculate the interest of banking accounts. And it works like, this, just less than a second. And then they said, that's fine, let's bring the application into the real environment. And it just took 8 hours in order to face the first error and just crash out of the system. And then it was the first project that I had, so it was very stressful, and I asked one of my friends to help me. He said, why don't you use SQL? I said, what are you talking about? He said, it's a store procedure, which is in the side of the database. So instead of just bringing with ADODB all the information from the database into our application, which needs and engage several parameters that are invisible, like bandwidth, like the policy of the network, and these kind of things. Instead of that, let's use store procedure. So right now, just look at this picture, and it rings the bell for you. It's just exactly like the architecture that we have in HADOOP environment. In HADOOP, we send the code to the different clients by job tracker, by task tracker and job tracker. The task tracker is responsible for any client. So we do not have any mobilizing in our data, and that's the beauty of HADOOP. That helps us in this area. Another experience that I had, the first day that I went to TI Department Trade Innovation, exactly was like this. All the branches, they started to work at 8 o'clock. They went to work and they pressed the enter button in order after setting the prompters. And it took 8 hours, and at 4 p.m. they received their reports. I said, there's something strange, and I asked my manager that, is it possible to manipulate the database? We do not have any contract, we didn't have any contract with the source of program, the company that was on the other side of the contract. But we, thanks heaven, we had the data source in our hands. We could manipulate the data. I just started to add some indexes on the criteria that they were checked in the report. As simple as that. As simple as that. And it reduced the time into 57 seconds compared to 8 hours. The first time that the manager said, reset your computer, he thought that I did some cheating or something. And he went to upstairs and checked it with his computer and said, wow. And everything, overnight procedures and these kind of things, changed dramatically. I saw the changes. And I'm bringing this experience because we have the same big amount of data inside HADOOP and these environments, but we suffer from having indexes. And if we can think about this issue, we may face a lot of increment in all aspects of our programming. Believe it or not, even to find out the appropriate words for searching inside Google environment could be kind of disaster. After 6 months of searching, my friend, which is concentrating on the Hadoop project in here, she told me that, you know that, Reza, the word that we searched and we couldn't find appropriate articles is wrong. I said, what do you mean by that? And that's one of the things that I'm going to tell you, and if you are interested in this area. First of all, I'm going to talk about the differences between SQL Server and Hadoop environment. And for sure, as they say, the necessity is the mother of invention. SQL could fulfill some of the areas that we had before, but something was missed there, and that is why that we come up with Hadoop solution or some similar things here. We are not going to eliminate one part on behalf of the other. For sure, there's a boundary for this, and there's a boundary for this, and we try to add some values to each of these solutions in order to have a better performance as a final result. And just to have a kind of abstract image in your mind, maybe in the lower layer of this pyramid, we may have Hadoop or these kind of big data application layers, and on top of them we can use SQL or any of these environments which are like this. So in SQL, we should use query optimization or index selection if we want to increase the performance in this environment. While in Hadoop, index selection cannot, bring you much result. The things that I told you. Partitioning is the thing that we really face. Just to tell you one example, one very simple example. Suppose this Best Buy in Dundas Street is number 101, and the laptop, the code of that laptop, for example, Lenovo, that laptop is 0070, and in previous day and yesterday they sold 50 of that. In the other branch, the same laptop, for example, 100 was the total sold. Most of the time in Hadoop, we deal with a part that we call it key and a part that we call it value. It works beautiful in these conditions, but it's a disaster if just you want to, for example, have a query based on the items. I want to know how much of this, specific product was sold all over the Toronto. So the problem starts there. And there are lots of solutions based on that. We may make a kind of overlay network and classify each item of the value part and make overlay network. But for sure, you know better than me that having each overlay network costs a lot. Another solution could be, for example, I use always specific product. I can use materialized view for that solution as well. That may cost a lot as well. And there are lots of strategies that I'm not going to make any more headache for you with them, like Cayley graph. Believe it or not, I just saw 90 minutes presentation based on Cayley graph, and I understood nothing out of it. It's so complicated, but it's one of the strategies that they used in order to make a kind of invisible overlay with the lowest possible cost over this network. And there are some combination of these strategies, like materialized view plus domain segmentation plus adaptive caching, and all of these are collected in one strategy that they call it eagle-eyed elephant, or triple E. So if you just look at the sorry, this is more recent. I took this picture, this figure yesterday from Indeed.com, and you can see for those who just want to study more about Hadoop, it's very promising. You know, that if you study, there is a wide range of possibilities for you to work with, and you can find this kind of exponential graph rarely in the IT environment. And if you want to start with, because Hadoop is a kind of sophisticated environment, and most of the articles related to that is a kind of vague, it's a good start. This book, which you can find the electric version from Toronto Library, or even the paper version from Toronto Library. This is a good start for Hadoop if you just, okay. So this was just my pre-presentation, and let's go to the presentation. Okay, I promise to. First of all, I'm going to show you the differences between SQL and Hadoop environment, structured and unstructured, relational table versus key value could be the second item. MapReduce is the most important part that I'm going to talk about: introduction, architecture, basic concepts. DBMS, database management system versus MapReduce. Advantage, pros and cons, which are deals with these environments, variants and improvements. So for sure, everybody knows that in SQL we have structured data, while in Hadoop we may face with different categories. There's this chance that I use multimedia content, and the variables that are not, fit enough with the normal, traditional RDBMS environments. So Hadoop is a kind of well-designed environment for dealing with these data types. As I told you, if you just imagine a kind of pyramid, in the lower segmentaries you can find Hadoop, and on top of that you can use SQL in order to get your traditional reports that you expect to have from any likewise environments. In previous, just in order to jog your memory, you remember this scale up and scale out. Hadoop is very appropriate for scaling out. Use commodity hardware. While in SQL environment, you should know what's the maximum amount of data that you're going to deal with. So you have to prepare for that amount of data by buying a bigger box. In SQL, for sure, you deal with relational databases, and it is complicated, time-consuming. Sometimes it's impossible to fit all your data in these kind of rules, which restrict your hand in order to lower your writing time. On the other hand, you may have a very simple format, key value in Hadoop. I'm not going to tell which one is better. As I told you, there's a preference. In banking system, definitely you should stay with the first or the left option rather than the right one. And not to mention, security is one of the disaster parts in Hadoop environment so far. And you have to think about it if you want to use it in a kind of high secure environments like banking systems. So in SQL environment, we always use query statements like what you see. Select something from tables. You have your own set of tables, relationship, and some restriction. Maybe you want to group by some of the columns. But in the right portion, you can use something similar to the language environments that you mostly use in your daily environments. MapReduce is simple, scalable, fault tolerance, but with that, expense to decrease your performance and efficiency. I'm going to tell you why the performance and efficiency is so down in the Hadoop environment. I told you before, I remember last session, we talked about this part. I told you, first we want to randomly load our data, which could be a gigantic amount of information. The one who is going to do that is a mapper phase, mapper function, which tries to map data inside different locations. This is a very simple function. I'm going to show you in a bigger slide because maybe the friends in the last seats cannot see profoundly. But in here, you can see the result in this intermediate phase is just mentioned as simple as that. In some references, you may see combined phase as well as compression. Suppose the information that you're dealing with is not as simple as that. For example, you are dealing with multimedia content. Should we just keep it like that? Definitely not. Definitely, we should compress this part of our information. Apart from that, instead of having, you see, DVD1, we may just make a kind of calculation in the middle phase. They call it combined if you've seen some articles. So we can give the output as DVD2 for the next phase. And the reducer is responsible here to add all the values and to make the final results here. Right? Okay, you may see the code more vividly here. It's a kind of pseudocode. You can manipulate in a Java environment easily. Just to know, the result without combined phase could be something like this. And if you want to have combined phase, it could be like this. And another, for example, suppose these are the two inputs that we pass to the reducer phase, and the result will be as a final result. Okay? You can see the basic idea.
Yeah. So I have a question.
Print, please.
What does the emit function?
Sorry.
The emit function?
Emit is what you, send to the other function. The mapper function is going to send these outputs to the reducer, okay? And the reducer take them as the inputs. And this is just a very prime example. As I told you, it's like, the hello world in all the languages, okay? That's the reason. I told you, first, you can see, maybe the picture shows that it is flawless, but you can find that the efficiency could be down in here because of no compression as a very basic idea that was in Hadoop. And we have just only the key in this phase. And if we can just manage to change the key based on the requirements and put it on the other object as well, this could be the phase that we can have higher performance. So we are going to manipulate this phase most of the time in order to increase our efficiency. So the map function to distribute data in partitions, I told you. Reduce function to aggregate results from partitions. And I told you previous session about HDFS Hadoop distributed file system. And data distribution, you see randomly distributed to map workers. There are some parameters. They use a very heuristic algorithm, a very simple heuristic algorithm in order to separate the information among the clients. Okay, everybody looks at the clock. So that heuristic can work profoundly sometimes, and it can reduce the final result in some other cases. Now I'm going to tell you both of them. So DBMS versus MapReduce. We may see in DBMS we generate a query plan tree for execution. The problem is Hadoop is a kind of runtime process. Okay, we may not have that pre-planned. So whatever we are talking about, query optimization is something which doesn't apply to Hadoop case. In Hadoop, a plan for execution in MapReduce is determined entirely at runtime. You see what are the problems? So debate. DBMSs have adopted one size fits all, while Hadoop is going to see a variety of different objects. Just to know, as I told you, one of the drawbacks, one of the cons of the Hadoop is its performance. It may have, at best, in compared to the traditional, 2 times more, it needs 2 times more time for performance, or till to 50 times more resources. You know, this is so much. And if you think about it, because of the redundancy that we should have, we said that Hadoop is a fault tolerance system. In that case, we pay the expense for that redundancy with the reducing our efficiency. So the good point about Hadoop is simplicity and easy to use, flexible, independent of the storage, fault tolerance, and high scalability. While we have problem in no high-level languages, like what we expect in SQL environment, no schema and no index. We may deal with some, we can say, semi-schema environments like XML as well. A single fixed data flow and low efficiency, and it is very young. In comparison, it's just 8-10 years experience behind it, while it's half a century history behind SQL environments. So variants and improvements could be high-level languages like Microsoft Scoop or Apache Pig or Apache Hive. They are the examples that try to bring semi-SQL environments to the Hadoop to make Hive, Pig, or these kind of things over Hadoop in this layer. Okay, so we may have the structure which we expected in SQL environments or likewise. We cannot say that it is not supporting schema. As I told you, it can support some schema like XML, and the very first experience dealing with this schema supporting issue was Google's optical buffers and JSON, and Apache Thrift. The other experience was like that. I told you about the flexible data flow. The problem is, and you will see, one of the subsidiaries of this part, which I mention later in the next slide as a separate category, is join. In Hadoop, we just have one step because it's block dependent. So how can I take care of simple loop? Because in loop, you have to, for the first time, I is 1. For the second round, I should be 2. But how we can keep this? And come in a kind of flat plane environment like Hadoop that we have. This is the problem that we are going to face. That is why the application Hadoop is going to tackle this problem with a kind of overlay environment. We have blocking operators. As I told you, Hadoop, this is the positive point about Hadoop, that every blocks work independently. But the problem is you have to finish all the blocks, then you can go and shift to the next step. Okay? So that's the problem. And for that, there are lots of, articles. The very recent one was talking about the sliding window. We just take a kind of sliding window. Temporarily, we just fetch the information from that sliding window, put it to the last, the next phase. You see, one of the other drawbacks of Hadoop environment is I/O optimization and index structure, which Hadoop++ is going to tackle this problem as well, is one of the proposals for this issue. And you see the picture, the whole picture is like this, and I just talked about one small portion of it. And there are lots of open-ended issues in Hadoop, and you can, work on it if you want to continue your education in higher level. It's one of the, issues that I'm going to, my friends in Australia, she's going to work on energy efficiency. And there are lots of things that you can, and nobody touched it so far. And the other thing is column-oriented storage and data compression. And as I told you, we have scheduling problem. Scheduling means, long story short, each computer should take care of the responsibility and should be aware of the time that receive the next process. We have two general strategies: fair scheduling or capacity. I told you about join. I don't want to go further inside it. And the other thing is performance tuning, which contains everything. And the last slide is going to talk about energy issues. Just think, because we have lots of clients, should we keep them all alive, or whenever there isn't any job for them, should we turn them off or turn them on? There are different strategies regarding to energy issues as well. And when they see, as I showed you the very first image here, and I unfortunately erased it, we are going to make a hybrid environments. And Hadoop DB is one of the hybrid environments that tries to get the most benefit out of both environments, or SQL MapReduce. Anyway, thanks to, bear this long presentation. Please, if there's any question.
One question.
Yeah.
You had on the disadvantages, that is no schema. For data coming in,
Yep.
how, if you don't know the structure of the data coming into the database, how would a schema help?
Okay. So we just use a schema in order, in the traditional environments, in order to protect our environment, not to accept any noise or garbage or these kind of things, and make the inconsistency and redundancy enough in a high level, okay? But in the time that we do not have any time to judge that, judge for these kind of things, what should we do then? We should eliminate that phase, and we should just think about it when we want to fetch the data, okay? We just move the schema rather than, the input phase into the output phase. Thank you, everybody.
Thanks.